Pretty close.
That's good.
It was
Pretty
pretty
good.
close.
Last night, I literally had to go to bed at 11. Okay.
Yeah, but
And I didn't fall asleep. Like, I could not sleep. I didn't fall asleep. And then I woke up at like 5.
It's Molly. It's
All
All right, so remember tomorrow there's a test. If you're not going to be in school, make sure you take the test anyway. It's on Delta Math. And the test will be open from 9:20 to 10:20. You have 45 minutes, so make sure you take it, please. So, any questions on the personal progress checks? Okay, which ones?
Just to clarify, the Unit 5 review is optional, right?
Yeah.
Okay.
Oh, well,
can we do some practice optimization problems?
yes.
Hi,
Do you have one in mind?
Uh,
how about you give us a problem,
yeah, and then we
Then
all
we do
try.
it. and then
I'm
And then,
like 5 minutes later,
yeah, that sounds good to me.
we go through it, yeah. Like 30 seconds later. we-
All right, so, I mean, does anyone have more specific questions? Because I don't, this could take a long time.
I know I had, I just don't know where it was.
I'll save the last like 15 minutes to do that, okay? If people don't have other specific questions. So specific questions on these?
Mine, I got the,
Yeah, my thing is taking forever to load.
All right, so then let me do an optimization problem. So I can actually look on here. 5.10 is optimization. So I can actually go up here and like go to a question bank, and it has like all questions on all different topics. So I can just click on 5.10 and it'll give me like all the optimization questions in the data bank or whatever. Now I have to be careful when I pick these because some of them, like this question has also topics from unit 9.4. So that's like not gonna be good for us. So let me see here.
What about 5.11, I think, so solving optimization problems?
Oh, it was 5.11? I thought it was 5.10. Oh yeah, thanks. Okay, so I mean, I could just pick any, do you want a multiple choice one or a free response one?
yeah,
Yeah.
you're welcome.
All of the above.
How about this one? Consider all right circular cylinders for which the sum of the height and the circumference is 30 centimeters. What's the radius of the one with maximum volume? Go.
Oh, boy.
These are all old AP questions on this site. I'll give you 2 minutes because that's how long they give you on the AP test. I'm just gonna work up here and you guys just work in, you're not done. Any questions? Okay. So you draw a picture, label variables, find the equation for what you're trying to maximize or minimize, its volume in this case. Find the constraint. The constraint here is that the sum of the height and the circumference is 30. So that's what I wrote here in symbols. Solve for the variable I'm trying to get rid of, which is just the one that's easiest to get rid of. You can get rid of either one, it doesn't matter, right? Then substitute it in, simplify because that makes the differentiation easier. Then differentiate and solve for 0. Now, technically, if this was a free response question, you'd have to do a little sign chart to indicate that you have checked to make sure that 10 over pi yields a maximum volume and not a minimum volume. But in this case, it's multiple choice. I'm not going to waste my time because I know it has to turn out that way. So. Okay, any questions on that? Okay, specific questions now, and then I'll do another one if we have time, or any other type of problem you want. Questions? You guys got to be prepared with questions on a day like this. You want me to just do problems again? More problems? By the way, I'm a little disappointed. I looked at this morning to see who had completed their personal progress checks, and there were 4 people who hadn't even started them today, which you're screwed for the test. Yeah.
Can you do question 9 on multiple choice question?
Yes. Okay, so question 9. Whoops. Go home. Question 9 on part B. Here.
I'm just not sure how you know if it's an absolute or just a regular.
Okay. The graph of f double prime is given in this thing, and on this interval, there's one critical point which occurs at x equals 6, which is the following statements about the function on the interval of 1 to 9. Okay, so if you do the second derivative test here, f double prime of 6, f double prime of 6 is positive, which means that this function is concave up. If you have a concave up function and then there's 0 derivative point, and we don't know that, actually, hang on, there's one critical point which occurs at 6. We don't know for sure that it's a 0 derivative point, but we know it's a critical point. The second derivative test is only valid for 0 derivative points, right? So my initial inclination is to say that the second derivative test is inconclusive here. Like, we don't really know whether it's a max or a min, but let's see if we can deduce that there is a 0 derivative. Like, I know that critical points occur at endpoints, 0 derivative points, and undefined derivative points, right? But the thing is, if it's an undefined derivative point, then the second derivative is also going to be undefined, right? And in this case, the second derivative is not undefined, right? So I think in this case, we can conclude that there's actually a 0 derivative point at 6, so there has to be a relative min at that point. Let's see if that's the correct answer. Relative min, but not, okay, so we don't know, that's the question. Okay, so they're asking us, I mean, we could definitely like eliminate these two, right? And it's one of these. So how can you tell if it's an absolute or a relative? Well, if there's only one critical point and it's a relative min, that has to be the absolute min, right? Let's think about it. Yeah, right? If you have a function that only contains one critical points are all the potential maxes and mins are contained in the critical points. So if there's only one critical point and it's a relative min, actually, I'm trying to think graphically. You have a situation where there's a relative min, but not an absolute min. and there's only one critical point. I can't think of a situation like that graphically. Because I'm thinking like if the function has a relative min like that, right? But this is not the absolute min, it's gonna have to like curve down like that, which would give you another critical point. You know what I mean? So I think the answer is that it's a relative, no, I'm sorry, it's an absolute min. I think the answer is B.
Yes.
That is the answer? Okay. You see my thought process though? So I'm trying to just think about like what's happening graphically and if it's possible. I'm basically trying to think of a counter example to what I thought was the answer. I couldn't think of one, so then that's what I thought is correct, yeah?
While you're on subject, can you also do 5?
Sure. Let G be this function. What's the absolute maximum on the interval from -4 to 1? Okay, so this would be the candidates test, right? So you find all the relative maximums and you just test them to see which one has the biggest y value. That's it. So G prime of x is the first times the derivative of the second plus the second times the derivative of the first. I'm going to take out an e to the x, make it easier to work with. And then this is x squared minus x plus 1 plus 2x minus 1. We'll let those cancel, with plus 1 minus 1. So you have e to the x times x squared plus x. If I set this equal to 0, I get x equals -1 and 0, because this is the only thing that can be 0. That can't be 0. So the critical points are at -1 and 0. There's no endpoints. Oh, there are endpoints. Sorry, there are endpoints right here. And there's no points where the derivative is undefined though. So my first derivative chart would be like G prime, look like this, -4, 1, -1, and 0. So I just need to determine when it's increasing and decreasing. If I plug in -2, I can ignore the e to the x part because that's always positive. So I'm trying to save time. So if I plug -2 in here, I get 4 minus 2, which is positive. If I plug -1/2 in here, I get 1/4 minus 1/2, which is negative. And if I plug in positive 1/2, it's 1/2 plus 1/2, or 1/4 plus 1/2, which is positive. So this is increasing, decreasing, increasing. So the relative maxes occur at -1 and +1, right? There's a max there, you can tell by the shape of the curve, and then since it increases to that point, that has to be a relative max as well. So then all you have to do is find g of -1 and g of +1, and just evaluate which one's bigger. So if you evaluate g of -1, it's 1 plus 1 plus 1 times e to the -1, which is 3 over e. If you evaluate it at 1, you get 1 minus 1 plus 1 times e, which those cancel and you get e. So which is bigger, 3 over e or e? Yeah, this is like 2.7. This is like 3 over 2.7, which is just slightly bigger than 1. This one's bigger, so this is the absolute max. And that's what they want. What's the absolute max? The answer is E. If they asked you, where does the maximum value occur? The answer would be at 1. So you have to be careful about that. You can see they gave you that choice because that's probably the most common wrong answer, is people selecting the x coordinate at which the absolute max occurs rather than the absolute max itself. Okay? Can I erase? All right, what else?
Can you do 11 on this one?
Sure. 11. Okay, so they're giving you, this is like a sign chart that's like super confusing looking, right? So the question's saying the function is twice, what does twice differentiable mean? Yeah, it means the derivative exists everywhere and the second derivative exists everywhere, right? Except at 6 where the derivatives do not exist at all. information about the first and second derivative for some values in the interval is given in the table, which of the following statements could be false. So what I would do is I would just translate this into a sign chart that looks more familiar to me. So that's what I would do. I would say f prime, the sign chart would look like this. We have the interval from 0 to 9. And if you look at the information, oh God, unknown. All right, that's kind of weird. So, like I'll just put a question mark, I guess, unknown. From 2 to 4, it's negative. That means it's decreasing. The function is decreasing. From 4 to 6, it's negative. So it's decreasing. From 6 to 8, it's positive. So that's increasing. And then it's unknown again. So that's what my first derivative sign chart looks like. And then the sign chart for the second derivative, put it on the same axes. From 0 to 4, it's negative, right? Including it too. So this is concave down. Then from 4 to 6, it's positive. And from 6 to 8, it's negative. And then it's unknown. Okay, so let's see if any of these could be false. The function has a relative maximum at 2. That definitely could be false, right? Because we don't know whether it's increasing or decreasing. Or if this was increasing, then it would definitely have to be a relative max. But we don't know that it is. I think the answer is A. Let's look at the other choices though. F has a point of inflection at 4. That's definitely true, right? Because it's definitely differentiable at 4, which means it's continuous, and the second derivative changes signs. That's what an inflection point is. So that one's definitely true. The function has a relative minimum at 6, also definitely true, right? It's differentiable, which means that it's continuous, and that it's decreasing and then increasing. The fact that the derivative doesn't exist, that just means that it has to be like a cusp or a corner or something like that, right? I know it's not a vertical tangent because a vertical tangent wouldn't go negative then positive. It would go negative then negative, or positive then positive, right? So I know it's like a corner or a cusp or something at that point, but definitely this is true. The graph has a point of inflection at 8. I don't know if that's true either.
Yeah, that's
Yeah,
what I'm
but they-
confused.
They can't.
Why can't that be
Yeah,
true?
no, I think it's.
Oh,
It is.
the answer is D.
But you can't prove that it has.
Oh, you know that this one's definitely true.
Yeah.
This one's definitely true by the second derivative test. The second derivative test, says if you have a zero derivative point and the second derivative is negative at that point, it has to be a max. So that one's definitely true.
Okay.
This is the only one that you don't know for sure is true. Okay? All right, what else?
Can you do question 3 on part A?
Sure. All right. That joke never gets old to me. Part,
Part E, the multiples.
number 3.
Look like that joke too.
Wait, what are you saying, Luke? You didn't like that joke? Okay. All right, this is a calculator question. It says the temperature inside a vehicle is modeled by the function f, where f is measured blah, 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 blah. The first derivative is given by this. At what times does the temperature attain a local minimum? I'd use my calculator for this, for sure. So if I use my calculator, I'm going to graph this function, x squared minus 3x plus cosine x. I want to make sure my calculator is in radians. It is. So then I'm going to graph it from 0 to 4, because that's what the domain they gave me is. So from 0 to 4, I'm going to do zoom fit. And you can see if it's positive, then negative, then positive, right? So the function, whatever the first derivative chart is gonna look like this. It's gonna be positive, then negative, then positive. So the question says, where does it attain a local minimum? It's gonna be at that point, whatever that point is, which I can use my calculator to find that point. I mean, I can kind of just see, it's gonna be 3 point something. It's one of these two. I'm not sure which one. It looks to me like it's probably this one. This is looks like closer to 3.3 than 3.5. So if I was just in a hurry, I'd pick that one. But I can actually verify that on my calculator. Do second calc, 0, left bound, right bound.
The first choice is 1.35, it's not 3.5, so.
Oh yeah,
that's the one.
I misread that. Yeah, you're right. So it's, the answer is 3.299. Yeah, I thought this said 3.54. Okay. I mean, you can see how they got their wrong answers. This is probably the other critical point. And then 1.962 is probably the minimum of that. It's like the low spot that they're trying to get you to, trying to trick you on. All right. What else? Want to just do another random problem on optimization or something else?
Do you have any like really hard ones?
Yeah, I mean, I can tell you one that I'm not including on the test that I considered including on the
Yes,
test.
we
Yeah. So there was there was a question. It was this? It was you take a circle, a circular piece of paper or whatever, and you cut out like a piece of it, and you just throw this piece away, and you take the stuff that's left, and you form a cone out of it. You get what I'm saying? So you take out this part and you just chuck it.
I remember doing a question like this in pre-prep last year. It was a group question the other night.
Yeah. And if this is the angle theta, what should theta be to maximize the volume of the cone?
Are those ones?
Those are ones, yeah, like 1 foot or whatever. Yeah, maximize the volume. What should theta be to maximize the volume? Oh, what's the formula for volume?
Yeah.
What's the formula for volume of the cone?
1/3.
1/3 pi r squared h. So, can we give you some time to work on this for a second?
Just like,
Okay.
Yeah, but what's the relationship between the theta and the, how long that side would be? Would that be yours?
How long? I'm not sure what side you're talking about.
Like of the circle, the part that's cut out, what's the, like the relationship between
Oh.
the theta and that?
Well, I mean, this here is going to be the total circumference, but it's just some percentage of it. It's like theta divided by 2 pi times 2 pi r. Right? Does that make sense? What was the question, Logan?
Nothing.
Okay. All right, so I'm going to work on it up here. You work on it there. Don't look up unless you need help.
These are calculator sheets.
What's that?
We can use a calculator sheets.
No, it's not.
Okay. I don't want to move fast.
Nom, nom, nom. All right, so let's do this problem. You're trying to maximize the volume, 1/3 pi r squared h, where h and r are the dimensions of the cone, not the dimensions of the circle. So the relationship is, right, this radius of the original circle is the slant height of the cone, for sure, right? So the relationship here is the Pythagorean theorem. It's easiest if you solve for r squared, because then you don't have any radicals to work with, and you just end up with a polynomial. Take the derivative, set it equal to 0, you end up with h has to be the square root of 1/3. Cool? But then if h is the square root of 1/3, then r is the square root of 2/3, and the circumference of the top of the cone ends up being 2 pi times the square root of 2/3. But that circumference of the top of the cone is actually the same as like this partial circumference of the circle, right? But that's equal, if this is pi over 2 pi, that percentage of the entire circumference, then this is going to be 2 pi minus theta over 2 pi, right? That's what this distance is 2 pi minus theta over 2 pi times 2 pi r. But r is 1. So that's what I did here. I just set the circumference of the cone equal to the partial circumference of the circle, and then just solve for theta. that make sense?
Yeah, have you forgotten that relationship though, between the,
Definitely, yeah, arc length formula.
Yeah.
The arc length formula, like if you have an arc like this, if this is A, this is just gonna be like 360 divided by, I'm sorry, A divided by 360. This is from geometry. A divided by 360 times 2 pi r. That's what that length is. But in radians, this would be A divided by 2 pi times 2 pi r. Does that make sense?
so why isn't that just A times all?
It is.
Oh,
Like this is really just theta. If this is theta, this is going to be 2 pi r minus theta, which is 2 pi r minus theta times 1. And the same thing goes for sector area. It's the same idea. Like the area of this sector is A over 360 times pi r squared, the area of the sector. Right? All right. Anything else?
do you have any more of those questions? Any big ones, all of it?
Not off the top of my head. I think there was another question that I threw out of the test.
The sign graph?
What's that?
Like the sign graph?
Sign graph. What do you mean?
You had a question that you took off for the test with the sign graph and then the rectangle and.
Oh, yeah.
So you meant like that.
Let's- This is not even the right test. This is. No, this isn't the right test. This is the test before that. Yeah, I don't know. I don't really have anything handy. Anything else? Okay, I'm gonna stop recording.